Throughout this video, we will discuss factors contributing to urban flooding on the East Coast of the United States. We will discuss things like the climate normals of the region, the impacts of changing land use, and the challenges of urban flooding. Climate normals are one way we can measure changes in climate over time. Normals are measured for 30-year periods. Two key historical measurements are precipitation and temperature. Other climate indicators we will review are the anticipated trends in evapotranspiration and soil moisture content. But ultimately, those circle back to two things: precipitation and temperature. The most recent update of the 30-year climate normals highlights some ongoing trends in the hydroclimate of the U.S. The U.S. Climate Normals collection now has 10 versions and is able to compare the most recent climate normals to the 20th century baseline. The annual climate normals are indicating to us that there is an increase in precipitation. But is that trend equally distributed over the whole year? It turns out no, it's not. When the normals are broken down by season, it appears that the winters and summers are getting more precipitation than the springs and falls. More precipitation in a shorter time is a contributor to urban flooding. A Colorado State study published in 2021 looked at changes in regional hydroclimatology through the 21st century for megaregions in the U.S. The study showed that the Northeast region is likely to have increased precipitation. The climate normal studies are projecting to us that the East Coast is going to get warmer and wetter. So where is this water going to go? Some of it will be moved back to the atmosphere through evapotranspiration, but in urban areas, that is not necessarily the case. This map shows the impacts of urbanization on ET. Soil moisture content is a key element of flooding. If the soil moisture content is high, then the water can't infiltrate. This recently published study shows the potential soil moisture for the 21st century. Let's zoom in real quick to the East Coast. That's right, the soil moisture trends are expected to increase, meaning less room for water to infiltrate. The final climate element we want to look at is weather extremes. As you can see from this figure, it's anticipated that not only will the East Coast be getting wetter, but the precipitation is going to come in more extreme events. Sometimes these are called pluvials. Areas that are urbanized tend to have limitations for infiltration and evaporation. Sure, there are regulations in place now to help mitigate future development, but not for the past. And the U.S. Census Bureau indicates that while some states are growing faster than others, every state in the Northeast is growing. More people means more housing, schools, roads, and other impervious infrastructure. Very few regulatory agencies are requiring developers and engineers to design for future conditions. Urban flooding is different than riverine flooding. These are the FEMA definitions. So what makes urban flooding so challenging? Urban flooding is challenging because it's hard to predict and is influenced by humans. Many factors can cause urban flooding: a blocked pipe, a yard inlet covered in leaves, but they are each the result of human impact. Your neighbor might add a deck and alter the flow of water, pushing it into your basement. Trash and sediment can also block stormwater systems. Adequately maintaining a system can be costly and intrusive. So what are some things we can do to help combat urban flooding? Think about developing regulations that consider the future, providing funding to design and construct upgraded infrastructure, and educate.